Hey everyone, this is my second video now. It's the trial of a new idea. Instead of the logical approach, I can also do videos on the following. And this time, I enlisted the help of some special aids. Ooh, whiteboard. I was going to talk about some of the things that bug me about math and science. Um, One of them being the improper use of the plus and minus terms in mathematics. I'll illustrate that with use of the whiteboard. Don't worry, I'm not going to make you do the math. It's just a simple equation not really pertaining to anything. But let's say we have the following, and we're trying to isolate for x. That is to say, to get x on the one side. So what you would have to do is you'd have to take this 5 here. Let me see here. This 5 here, and you'd multiply both sides by 5. Now, what some people will say is times both sides by 5. That's incorrect. It bothers me a lot, actually. But that's not the one that bothers me the most. So after we multiply both sides by 5, we have something like this. And from here, what we have to do is we have to take this 3, and we have to subtract 3 from both sides. This bothers me a lot more than the multiplication term one. People will say minus 3 from both sides. That's not correct. It would be correct if we have something as follows. We read the following as 5 minus 3. We can read it like that, but you can't use the terms interchangeably while you're applying them as such. So if you apply them, you say subtract. So you subtract them from both sides, but when you're just reading it to someone or narrating, you can say 3 minus 5. Same goes for addition. A multiplication, same thing goes. You can say times, so 2 times 5, but when you want to multiply both sides by 5, you have to use the term multiply and not times. Before moving on to my next thing that bugs me, and this one will be pertaining to physics precisely, I will discuss a fun factoid that I have. It's relating to, it's more of a history class really. It's relating to a Roman clock. If you ever see a Roman clock, you'll notice something as follows. So here I have Roman numerals from 1 to 12 going across the top here and the below. Take special note to number 3. So 1, 2, 3. 3 is 3 I's, whereas 4 is an IV, and then 5 is V. So that's important. When you see a Roman numeral clock, if the people who make the clock are being authentic, they will show the following. Here we have 12, right? Then it goes 1, 2, 3, 4. But notice this 4 here, instead of being 4 like up here, IV, it's being an I. The reason for this is quite interesting, actually. It's a history lesson. Back in the time, Julius Caesar was in charge of the whole place down there in Rome. And what happened was, the way you used to spell capital J's in Roman times was like this, IV. Well, it looked like an IV, but it was really a capital J. And he wanted to restrict that for his own name, a capital letter J. So anyone clockmaker who used his letter, the capital J, on a clock, he would personally decapitate. Well, when I say personally, I mean he would have them decapitated, not necessarily he would personally get decapitated. So yeah, that's an interesting factoid. Now I want to talk about something that bugs me in physics. People will often use the word decelerate to describe negative acceleration. I find this absurd. Even some physics textbooks use the word deceleration. I find it absolutely absurd that they would use deceleration when I would use the word negative acceleration. Now maybe it's just me, but I believe, and strongly believe, that negative acceleration is more proper, and I'll show you that through use of visual aids. So to explain this further, you have to know that acceleration is the rate of change of velocity. So if you have something like this, well, velocity changes constantly. So the rate of change of velocity is not linear. So see how it's kind of quadratic? Then we can see that acceleration is occurring in a linear fashion. So right here we have increasing a rate of change of velocity that's increasing exponentially like this. At point B, we can see that the acceleration is changing, so some people might call that deceleration. We can see that more clearly in this graph here. So from this point, on this point here, to point A, we have an increase in acceleration. From A to B, we have a decreasing acceleration. Now, since acceleration is the rate of change of velocity, we can see a positive slope from here to A, which is acceleration, positive acceleration, and from A to B, we can see a negative slope or negative acceleration, not deceleration. Because what would deceleration be? The opposite of acceleration, and I personally don't know what that would be. So that's my problem with acceleration or the use of the word deceleration. One last interesting tidbit. So if you had a cat or a small child that drank enough coolant fluid from a cow, or sometimes known as radiator fluid, they would die. And the reason for that is that the radiator fluid would go into the would be digested by your body, and it would change the pH of the blood, and that would cause your hemoglobin not to be able to hold on to oxygen, and basically you won't be able to breathe because your cells don't get enough oxygen. You can avert that by making them digest either your cat or your with the small child, whatever will digest it, by making them digest ethyl methanol, which is the alcohol in beer, common beer and wine. And what that's going to do is your body more readily digest ethyl methanol than the active ingredient in coolant fluid. And what will happen is it'll digest the alcohol instead, the methyl-methanol, and the coolant fluid will come on the urine, and it won't lower your pH as much. So that's a possible way to save the life. But in no way, shape, or form should that replace calling 911 or poison control. Don't take my advice for that. I could be lying to you for all you know. I'm not, but I could be. So call 911 or poison control first. That's just my disclaimer. And other than that, I'm done for now. So I hope you enjoyed this video, and I hope you subscribe or comment below. Have a good one, guys.